Hello everyone, my name is Laurynas Lubys. I'm a backend developer at Wix. In my job, currently I mostly work with Scala, but today I'll be talking about Node. And I did quite a bit of Node development in my previous position at Wix. So yeah, there's not that many of us here, so feel free to interrupt me with any questions if you have any. We'll have enough time for some discussions. So the agenda for today is, first of all, we'll talk about Graal, Truffle, and GraalVM. What are those, and how do all of those things help us use JVM libraries in Node? Then we'll talk a bit about interoperability between Node.js and JVM in this case, and we'll get our hands dirty with some examples regarding synchronous interoperability and asynchronous interoperability. So, what is Graal? Recently, a new interface was introduced into the JVM, which is called the Jvm Compiler Interface, or to be more specific, it's a compiler. It's an interface for just-in-time compilers. So all the previous versions of JDKs, well, most of the JDKs shipped with their own version of a just-in-time compiler written in C. So with Oracle's JVM, that was C2, and well, people figured that writing code in C is not easy, and the just-in-time compiler is not a simple piece of code. So you would like to write it in a more safe and more maintainable language than just plain old C. And yeah, Graal is exactly a just-in-time compiler that implements this interface, and you can plug it in to your JVM. The compiler interface ships, I think, from JDK 8, from some later versions of JDK 8, and it's like the interface is there for all the later ones, and Graal itself is included by default, if I remember correctly, in the Oracle JDKs from version 11 up. So you have it, you may not be using it, but you have it, and you can just enable it with a command line argument. Truffle is another thing. So I'm just throwing these terms at you, but this is sort of important here. Truffle is a framework for defining abstract syntax trees for other languages, not Java. And why that's important here is because, well, we'll find it out later, but it just allows us to write better interpreters for these languages that are automatically just-in-time compiled by Graal, just as if they were native Java code. And finally, we have GraalVM, which is just the distribution of the JDK with all these libraries included, and additionally, it includes a Node.js build that actually works in this environment, and that's the one we'll be using. So how this works usually, well, up to previous versions of JDKs. So you have your source, which can be a Java source or a Scala source. You compile it to bytecode, which is usually packaged in class files, and then you give this bytecode to the JVM, and JVM looks at it and either interprets it, or it usually just-in-time compiles it into native code, which actually runs on your processor. What happens with Graal is that instead of, well, I mean, it's not only in Graal, but so what you have now is you compile your sources into bytecode. Graal transforms that bytecode into a graph structure, which doesn't really matter how it exactly looks, but transforms it into some intermediate structure, and then just-in-time compiles it inside of the JVM. And where Truffle comes in here is that Truffle allows you to take other languages, for example, JavaScript, and instead of going through some loops to make it look like Java bytecode, instead, you can transform it directly to that intermediate structure that Graal uses and just-in-time compiles to runnable code, to code that executes on your processor. What this gives you is that now you get all the same optimizations as you would get if it were written in Java and compiled to bytecode. So that's the basic overview of what's here. There's a bunch of other things that are interesting about Graal. It like allows you to write custom, for example, custom just-in-time optimization rules that you can plug in because it's just Java, and yeah, so it's pretty cool. So, how do you use a JVM library in Node.js? Well, first of all, you can open the documentation for the GraalJS project. So, GraalJS project is the part of the GraalVM which which allows you to basically run JavaScript on Graal, and also it has a distribution of the node of Node.js. So these are pretty good links to the documentation. It's that there's not that much documentation, but it's pretty good and it's really enough to get you started. So, but the TLDR is specifically with using stuff from Node is that you get a drop-in replacement for Node.js, which should be mostly compatible with existing libraries. And the way it works is that you have your JDK with Graal, and then on top of that you have Truffle, and Node is running on top of Truffle. So Truffle is used as the interpreter for JavaScript, and there's also like binding with C stuff. So it's actually really magical how all that works. But from our perspective, if we want to, once we have this Node binary, if we want to enable Jvm Interoperability, we just start the Node interpreter with --jvm, and what we get is we get access to all our Java code, and the boundary between your Java and Node is really not that noticeable. So, for example, if you have a Java function Java method that expects a string, you just give it you just call it with a string from JavaScript. You don't need to like construct some intermediate representation, marshal it, or something like that. So you get everything in memory and really efficient. If you have a Java method that accepts a map, you can just pass it a JavaScript object, and it will be automatically transformed to a JS map. And there's to a regular map. And there's a whole bunch of other niceties that make this boundary really not that noticeable. So, so let's see how it works. So here, just so to show that I have no tricks up my sleeve, so I have a node distribution in my path, which comes from GraalVM, and you just run it with --jvm, and it starts up. It takes a bit longer than regular Node, and it actually works for simple stuff. And if we want to use some Java code, let's try printing something to the console. Of course, we could just console log something, but let's make it harder on ourselves. So the way you do this is when you're running the GraalVM with --jvm, you get a global object called Java, which gives you access to the Java world, and we can then get a reference to the Java long system class, which is our trusty system thing we use for system out println. So now what we can do, we can say system out println, and we can just hello world, print it out, and it works. So that's pretty cool, and we didn't have to do any wrapping or anything. We just called it with a string because it accepts a string, so expects a string. So yeah, that's great. So let's then make it even harder on ourselves. So let's try to actually use a library in Node.js. And in our first case, we'll just use a simple library just that does some work synchronously. You just give it some arguments and it passes something back. And for the sake of our example, we'll be using Bcrypt. And Bcrypt is a hashing function with a knob you can turn to change the computational resources needed to calculate the hash so that it's harder to brute force. The idea actually behind Bcrypt is that it has to be computationally expensive, because that's the point. So yeah, there's plenty of really good Node libraries for that. That implement Bcrypt, but just for the sake of an example, we'll try to use one, and we can just think that maybe this is a stand-in for some cryptography library that you already have for the JVM, and you don't really want to re-implement on top of Node, because now if you have that situation where you have some library in Java, if you want to have it on Node, well, you have to completely re-implement it. So, or it could be like, I don't know, parsing Excel files, which is a problem that no one wants to solve on Node because it's a really annoying problem. So what we'll do, we'll use the JVM library called JBcrypt, and then we'll integrate it into our Express server and handle user logins with that. So the plan is, first of all, of course, we'll need to tell the JVM where to find the jar, because, well, since it's the JVM, it needs to know where it can find classes. Then we'll call it from Node. Finally, we get to integrate it into our application, and then we get to go home early because, well, we just saved a whole bunch of work because we didn't need to like re-implement a whole library. Instead, we just used an existing one. How do we tell the JVM where to find the jar? So there's two options. You can, when starting the node executable, you can pass in -jvm.cp and provide the class path there, or you can add it at runtime using java.add-to-class-path. Yeah, so let's do exactly that. So first of all, we need to add the relevant entry to our class path. So I have add to class path. It's right here. So now we have it in our class path, and now we can try to load it. So let's say var bcrypt equals java type org mindrot. Like in this case, the long package names really start to bother you. Okay, bcrypt. And now we have a reference to that class. And that, like, funnily enough, we can actually see all the static functions it has, which is really convenient. And we can actually, well, we can see that the way bcrypt works, you need a salt and a password to hash it. So first of all, we need a salt. So we'll just say, well, var salt equals bcrypt.guns. Oh, shit. I don't know what that was. That was something new. At the class path, bcrypt. What was that, by the way? Well, I guess, well, this is one of those examples of like, well, this is still experimental technology, because I have no idea what happened there. That's one long stack frame. Okay, so let's generate a salt. And actually what happened, I just pressed tab. So I don't know why that crashed it, but it did. So let's scan salt. And here we have our salt. And now bcrypt dot hash password. And of course, we need to use a good password. So it's password. And here we have a hash of that password. And we can use a different one, and we'll see that the hash is a bit different. Yeah. So far so good, right? We can now move on to the next part. So now we can integrate into our application. I won't bore you with that because it's, as we saw, it's really simple. So we'll just add a route for login. We'll take the password from the login parameters, and we'll, for some reason, just echo back the hash of the password you just passed in. But this is just for demonstration purposes. So let's see how that works. So let's start the server. Jvm and start Bcrypt. And one thing you'll notice is that it starts way slower than Node would. And it's especially visible with NPM because NPM starts a node process and then it starts another node process. So it's actually starting up the JVM twice, but it's already listening for requests. Let's see if it actually responds to requests. So localhost. And here we get our welcome message. So we can try to log in now. We need to post this time. Nope. That's not how URLs work. That's how URLs work. Yeah, and we get the hash. So cool. It looks like it works. Let's. So yeah, but just that because it serves requests doesn't mean that it's good enough. So let's see how it would handle some load. So let's start up a very basic benchmark. One //host. Right, so we can see that it's when we started up, it was handling like around 200 requests per second. As it's warming up, we see that it's getting better, and well, but it still takes quite some time to actually warm up and to just-in-time compile everything. And if everything goes well, it should reach around 8,000 requests per second, which is pretty respectable considering that the same script minus the hashing, the password part on my machine, squeezes out around 1,600, 16,000 requests per second. So it's 50% less, but it's not like, it's only 50% less. It's not like 20 times less. So that's pretty good, right? Cool, so yeah, ship it. Well, we go to deploy it. We imagine these are the numbers that we will get. And then people start logging in. So as we can see, we have our 8,000 requests per second. It's a bit, going up and down because of GC pauses probably and stuff. I don't know why, but it's pretty good. And let's say that every 1 second, a person starts to log in. So a person logs in, we wait 1 second, and then log in again. So what happens then? Well, we can see that our requests per second dropped significantly. And now it's recovered again, probably, almost recovered, probably just-in-time compilation and stuff. Who knows? Well, but that's still reasonable. Okay, let's say we just have a user logging in like back-to-back. So they send a request, get a response, send a request, get a response without waiting at all. What do we get then? Well, what do we get then is that now we are really starting to struggle, and we only get like 1,500 requests per second. And if we actually start doing it concurrently, right? So now one thread is logging in, and now we have 2 threads calling the login, and it's now it's really bad. So I guess we don't get to ship it, and we don't get to go home early. So what happened here is we blocked the event loop, and this is like one of the major issues, I guess. Well, with conceptually using these libraries, using JVM libraries in Node, is because in JVM it's perfectly fine to block the calling thread until you are done processing, but if you do that to a Node application, it really starts to suffer. Well, fortunately, so we didn't get to go home early, but if you're using Node, you know how to deal with stuff like this. So you start a worker thread, and you send your request to the worker thread, and if the worker thread blocks, that's fine, but your main thread does not block, and you can still handle other requests while everything's going on. So not ideal, but doable. Yeah. Any questions so far? No. Okay. Yeah. So, and now, yes. So the summary here would be it's not trivial, but it works for the most part. Now let's talk about. So now we know that if we want to use just any old regular Java library, we need to make sure that we don't block the main event loop. So that's kind of a pain, but I mean, we can deal with that. So what about asynchronous libraries? For example, we want to consume messages from Rabbitmq. Of course, there's a Rabbitmq library for Node, but just as an example. And we don't want to use any poll API. We want to use the Rabbitmq Push API. So what we want to happen is we register. What we want to happen is that we will register a listener, and whenever a message is published to a topic, our listener is immediately called and receives this message and can act accordingly. So, in order to do that, what we'll need to do, first of all, we'll need to figure out, I guess, how to do callbacks with Graal, because, well, does it work? Secondly, we'll define a simple Java API, mock API for for a message queue for such an API, because the actual API is a bit more messy, but that's fine. And then we'll implement this callback in Node, and then we'll finally handle a Rabbitmq message in Node, which is going to be awesome, using a JVM library. So, how to do callbacks with Graal? So one really simple example of a callback is iterating collections, right? So on Java, for example, on Java lists, you have a method for each, which accepts a function, and that function gets called with every element in the collection. So let's try to do that. So first of all, let's get a reference to array list, because that's one implementation of a list. Array list. Now let's create a new instance of this list. So as you can see, it's super easy. We have a Java list here. We can add items to it. So let's add some items. Let's add one, and let's add a string, and then let's add a object. And well, yeah, as you know, Java array list is it has a generic interface, but at runtime it's just storing a whole bunch of objects. So this is completely fine. And now what we can do is we can iterate it using for each. So let's do that. So let's give it a lambda then, which will print the stuff. To the console. And here you go. See, it works. Actually, it's so nice that you don't need, it's not that only you can use lambdas, you can just pass in a reference to a method on a object, and that will also work. Cool, so that's really straightforward and simple. Yeah, so let's then, what we'll do next, we'll define this interface for a message queue. I mean, usually you would have a much more complicated thing here, but in our case, we just need a method to initialize it. We need a method to add a consumer for a specific queue, and we need an interface that the consumer or handler has to implement. In this case, we'll assume that the message is a string, and yeah. So how do we implement it in Node? Actually, it's much easier than you would think. So yeah, we get a reference to our queue, we initialize it, and let's say we want to just log the messages to the console. So we can just say that handle message is equals to the method console. Well, it's a reference to the console.log function. We initialize the queue, and we can just add the consumer directly without actually having to like extend any classes or anything, because it Graal automatically transforms JavaScript functions into single method interfaces. So since we expect a single method interface there, it makes the function work there as well, which is really nice. And I guess we can then just send a message and see it get printed, right? Let's split it like this. And npm --jvm run start. So we start our application that will just register a listener, and we'll try to consume the message there. Hopefully we don't have any messages pending currently, so it doesn't, yeah. And it actually logs that when you register a handler. So we see that it sort of worked, at least registering the function, the handler worked. It says that the message handler was registered, and it's listening on hello rabbit. Now let's try to post a message. So, hello Node. And this time, it didn't work. And the reason why it didn't work is here. Multi-threaded access requested by thread blah blah, but is not allowed for language JS. So, yeah, obviously, we can't call JavaScript from another thread, and you would think that this is maybe, you could think that this may be like an unfair restriction, but when you think about it, it's good that you can't call JavaScript from another thread, because you don't have any synchronization primitives. Well, not like you just have one thread in JavaScript, so you don't have any concept of how stuff can change outside of your code, because all the interactions happen through events and everything happens on the main loop. So that would probably be a bad idea to just mess with stuff directly. And does that mean we can't do this? Well, not exactly. So let's imagine that we have this thing called bind callback, which the way it will work is we give a JavaScript function to bind callback, and we get a Java object, well, like actually a Java function, which then can be called from a different thread, and it will actually trigger that original JavaScript function, but in a safe way without blowing up. So what we would like to have from this function, and this is going to be a bit of a messy example, but this covers kind of the whole spectrum of what what we're trying to achieve here. So let's say we have some library that magically provides this bind callback thing, and we have a Java class something async, which has a method which is called callMeBack. So let's first concentrate on this part. So what the callMeBack method does is it gets a function, it waits a bit, and it waits on a different thread. It calls that function from that different thread, and then additionally it will also want to know when the other side completed handling the result it provided. So what we would get here is that we want to pass it in a function that when the JavaScript function will just log stuff to the console. So what we want to do, yes, so when this thing calls this function, which is there, it will log Node.js results to the console, and then after 100 milliseconds, it will resolve the promise with hey, and something async will get that hey. So if we run it, we expect output like that. So as you can see, nothing is blocking here. So first of all, this line is executed, so we get let's wait now. Then this thing posts, like this thing invokes the bound callback. So this is executed. Then some time passes, this one executes, and then this one logs the hey that came from there. It's a bit much, but this is kind of what you need to. In this case, why we want exactly this functionality is because, well, if you're handling a message, right, you probably need to say if you succeeded in handling the message or you did not. Because otherwise, you could, like if stuff fails and the Rabbitmq or the message queue, you have no way to notifying the message queue library that, oh, I failed handling this message, and you're in a bit of trouble because, of course, you can implement it differently, but this is just a way where it covers the full spectrum and what you would actually need to fully interoperate like that. Yes. Unfortunately, GraalJS does not provide that out of the box, and I'm not sure if they're planning to do that. If you want to actually do it the other way around, if you have your JVM application and you want to use some specific Node library, there is a library and a package. I don't remember how actually it's called, but there is a package that you can just download and use. And of course, that does also mean that you'll need to be actually running Node, and your main, it will call your main application. It's weird, but I mean, that part is provided by another party. And yeah, so GraalJS does not provide that out of the box, but let's see if we can build something like that. Yeah, and warning, it's not going to be super simple, but I'll try to. I mean, this is, in a sort of way, this is just an interesting thing about how you can invoke a function without actually invoking it. So if you ever come into a situation where you need that, you can do this trick. So let's say we have this JavaScript function represented by the purple triangle, and we want to call it with the sync results from Java, and then we want to send the results back. So we take this function, we give it to this block, which is something that's running in the Java land. So we give it that function, and it gives us back this other thingy. So this is, I call it their bound JS callback. So it's just it's actually just a container for the JavaScript function. So it's it only has a reference to the JS function. And then, but this thing can be called. And when you call it, we'll see what happens. So you bind your callback, you get back this bound callback, which can be called from Java code. You give it to some asynchronous Java code. It doesn't block. It returns immediately, and some time later, it wants to signal to this function that either it completed or failed. So we either give it an error result or a success result. And additionally, what it wants to do, so when this Java code calls this function, it gets back a promise which will be resolved when the JavaScript part deems it appropriate to say that, okay, I handled this response, and I handled this, and it either succeeded or failed. So obviously, those things. So yeah, that's my syntax for calling the JavaScript function. So what we want to do then, in the main node process, we want to call that triangle with the lightning or the successful result, and then we want to complete the promise. So, but now we're in a bit of a pickle because we're in here deep in Java land, and we have no way to get back to the node land. So what we can do is we can introduce a whole bunch of components. Yeah, and so the components that we introduced here are, we need a worker a Node.js worker that blocks on a queue living in Java land. So it takes a message from this queue, posts it using post message to the main node process, and then blocks again on this queue. So it's just pumping messages from this queue to the main node process. And so what we can do with that then is we can just package all of these things into a thunk or something, or whatever we want to call it. We just package them all up. We put them into the queue. The Node.js worker pumps the message, gets the message, pumps it forward to the main process, and now we can actually just access these things and actually call the function with the appropriate arguments. Anything so far? Okay. Yeah, so this is pretty scary, and I guess it should be scary. And this doesn't cover a whole bunch of other questions, like how do we gracefully shut down, for example? Because we don't want to, like, while this is happening, right, while this thing has been called, but that was not handled, we probably don't want to shut down the node process because we'll lose some stuff in, like, that's in flight. So, for example, if you're handling a message, like a Rabbitmq message, right? So the Rabbitmq client would call this function and then would await for this promise. But if we kill the node process before this is resolved, well, we have a bad time. Moving on. Right, so I guess our plan wasn't like that, but now we need to implement handlers that can be called from a different thread. So the way we would do that, unfortunately, this time the trick with where GraalJS transparently implements single method interfaces for you doesn't work, because when it implements those interfaces, that's considered JavaScript code, so you can't call it again. So we need now to have a class that will wrap this bound.js callback, and that means we need, now this time we actually need some glue code, and we can't just rely on everything happening automatically. Yeah, but in general, this thing is just it just has a reference to that callback, and when a message is received, it will call that JS callback. And to use it, yeah, so those are, the grayed outlines are the same. So now we need to get an instance to the JS handler class. We need the bind callback magic function. And now we can actually define a handler, which we just call with new handler, and then we bind the console log method, and then it can actually safely be called from a different thread. So let's see how that works, shall we? So that one didn't work. So let's take two. And now when we call it, it actually works. And we actually see that the message is delivered there, and it's delivered pretty quickly. So what have we learned so far? Actually, I'm going towards the end of my presentation. So what we learned so far is that for synchronous code, like the interop is really good, and you don't really need to think much about like how you call stuff, but you need to think very much about will I block the event loop. Regarding asynchronous code, it's doable. Someone should really own up to it and build this as a library or something. But it's not exactly easy to do, and not exactly safe, especially if you, like, this is just a basic example, but you need to take care of, like, you don't want too many messages pending, for example. You don't want to, I mean, there's a whole bunch of operational stuff that would be really, really painful to actually get done fully and to make sure that this is good enough for, running on production. So if you want to use JVM libraries, you have to use Graal Node.js. I guess it might be possible to do other ways, but what I mean by this is like your whole Node application has to run inside Graal Node.js, which means you get a different performance characteristics, different as we saw, different startup times and different warm-up times, different GC behavior, so a whole bunch of stuff that is actually different. You can use libraries just as they are. However, most of them will need wrappers to deal with blocking or asynchrony. So yeah, if you imagine like working with, as I mentioned, Excel files, like if it were written in, the library were written in JavaScript, it would probably have a non-blocking API because it's CPU intensive and you don't want to do that on the main thread. And my last point is you probably can, but should you? So what I mean by this again is it's definitely doable, but you really need to have a really good reason to do something like that. Because yeah, you can just implement a different service and call that in most cases. So there's really not that many cases where you can't really do this, but like I said, there might be some. So for example, a good example would be if you have some authentication logic, let's say, or something dealing with a cryptography and stuff like that, which you don't really want to re-implement in multiple languages, and you don't want to be, remote. So you want to do it exactly on the machine you are on, because otherwise you get a bunch of chatter between services. So yeah, I guess thank you. We'll have a bit of time for discussion. I have to mention my colleagues who worked on this as well. So that would be Pius Navickas and Milda Glebauskaitė from our Vilnius office, and Gleb Alexeyev and Viktor Polishchuk from our Ukraine office. And yeah, I'm open to questions now. Yep. No. It's that simple. As I said, you need to really have a good reason, because it's quite different. And like, I mean, maybe sometime down the line, and it's really cool. Like what they have achieved. It's like, that experience where you just get a Java class and you just call it. No problem. That's really amazing. But using it in production might be painful. Yep. Sorry. So yeah, basically what kind of problems you can solve with this approach, and you can solve it in different ways as well. So I guess the main reason is if you have a JVM library that solves exactly the problem you have, and there's no equivalent library in your host language, and you don't want to start a separate microservice just for that one thing. So examples that come to mind, for example, there's a really good Python library, and yeah, you can also do similar stuff with Python and Ruby, I think. And R. They ship these interpreters, but for example, there's a really good library in Python for parsing email signatures. So if you get an email and there's a signature, and like the rules, it's not so rules, but like the heuristics to figure out which part of the text is your message and which is just a like footer that should be hidden, those are super ugly, and no one just wants to implement them at all. Or for example, there's a really good Java library, but I think they actually have some libraries in other languages as well for dealing with phone numbers. So Google lib phone number, and it's another one of those problems where just no one wants to solve them, because it's messy. It's like, well, the standard is like this, but like these countries do it differently. And well, this, but then these are all different. And you just need a whole bunch of time and a whole bunch of resources to deal with stuff like that. Fortunately, with the libphone number, they have libraries in, I think, in Node and in Python. But maybe if you wanted to use it from Ruby, then you don't have one. So do you just have a separate service that just only parses phone numbers? Which also is a bit of a waste. So it's just another tool in the toolbox in case you really need it. And as I said, it's not cheap because you just then have to wholesale move to it, and like probably most of your monitoring infrastructure is not going to be exactly the same, so it's going to be hell of expensive. Okay, so thank you.